Hi there. This is going to be probably a fairly long video that I'm going to do this time, because I'm trying to get a lot of information across to the viewers about what I intend doing regarding making a threaded spindle the same as the Taig headstock spindle that I then want to add to this unit, which in the previous videos you'll know that's the adapter that goes in the George Thomas dividing head. And so I had a problem in coming up with an idea of how I can produce a 3/4 16 thread on a piece of steel when I don't have a single point threading on this unit. And I did have a die, a brand new die, with and I have a die holder that I've had for years and years that would fit this die. This is the die here. I don't know, I can't remember now where I got it from, but it looks pretty good. And it's brand new. Now, when I tried to thread a piece of 3/4 inch steel, I don't know what the steel is either, I have no idea. I knew that I was fighting a losing battle. So I came up with an idea of getting around screw cutting and still being able to make a spindle that would fit the chucks of the 4-jaw chuck and the 3-jaw chuck of the Taig Lathe. And what I came up with is, first of all, I'll show you this. This is in the 4-jaw, and this is the adapter. And what I did was I drilled a hole in the center and bored it out. I'm going to bore it out to a 1/2 inch plus, a few thou. And the idea is that I can purchase a 3/4 16 bolt. I've already ordered, the smallest number I could get was 6 on eBay. I think it cost me $12, something like that, for 6 3/4 16 bolts. They look pretty good. The thread is not ground, obviously, but my idea is to use one of these bolts and slice it off to the length of thread that I require. And if you look at this rough drawing I've done here, I hope you can see this. I have the adapter. The adapter is here, that goes into the dividing head, and I chopped off the original thread that was on there and faced it off, and then I bored out a hole, a true hole running concentrically with the body. Now I've yet to finish boring this. I just roughed it out to roughly 50 thou under ½ inch, and so what I intend doing is to cut off a section. If you see this white section here, that's the bolt with the thread out here. I'm going to drill right through the section of bolt that I require. It's not very long, just enough to go into the chuck. I'm going to cut it off and drill the bolt right the way through, so it's like a tube with the thread on the outside. Now then, once I've done that, I'm then going to turn up a steel insert that is going to go in that bore, and it will in turn, that insert, which is made of steel, that's all of this here, because this part here where that line is meant to fit into this recess. Okay, now in turn I'm going to drill through the insert, the steel insert, so that I can attach a screw that goes through at the front end and screws up into here. Now that will lock this whole section into this bore here and should lock it solid. Now I'll probably use Loctite as well, just to make sure, but I may not do that, because this is just meant to go into a dividing head. It's not driven by a motor or anything. It's just a hand, it's just revolved by hand, the hand wheel. So I don't imagine that anything is going to move once it's locked into there. And then any chuck that I have work inside the chuck, and I've done it on the lathe, and then I want to take it over to the mill to do further work, then it should fit on here. Now the other thing is that the spindle on the Taig, the thread doesn't go all the way up to the face. Okay, there's a section where it's plain. Now I'm going to use that as a register, a constant register. In other words, I'm going to use it for the accuracy of the chuck being screwed on every time, because I imagine that this bolt that I'm purchased and going to use, it's going to be a loose fit on the chucks. It's not going to be a good fit like it is on the Taig, and so I consider that to be a register, because that register measures about 0.504 in diameter, whereas the rest of the thread on the Taig lathe is undersize. It's under half inch. So to me, this is going to be similar to the old-fashioned way that they used to do years ago in locating chucks on lathes. Most of the lathes, I believe I'm right in saying, had what they call a register. That I had a Drummond, Myford Drummond 3.5 inch lathe, and the thread was a 1 inch 12 thread, and at the very end, if I can show you this, this is the type of spindles that used to be on lathes years ago. other than the cam locks or tapered noses like Hardinge and stuff like that, which are much more expensive and quality machines. But on these smaller machines, they would have a register, which in the Drummond case it was a 1-inch diameter thread, and the register was about 1/4 of an inch wide, there, and it was 1 1/8 diameter. So the theory was that the thread, when you were putting the chuck on, could be as loose as anything, could actually wobble around. But once it started to locate on the register, if it was a good fit in the chuck, that would centralize the chuck up and give you trueness, repeatable trueness. So that's what I'm trying to obtain in this description here, in this job that I'm doing. I don't know what more I can tell you about that. The newer machines now, like the shear line and even larger lathes, I'm not sure about, but they seem to rely on the thread and the fit. And it's really my opinion that in the hobby trade there's a lot of novices and people that are interested in coming into the hobby, but they don't know very much about it. And screw cutting seems to be one of the daunting things for the newcomer. And so I figure that in this particular instance, if somebody was making a back plate for a lathe, for a chuck, then I think personally that this would be a much easier operation for them to do, rather than to rely on a precision fit of the two mating threads, one on the spindle like the shear line, which doesn't have any register. It relies solely on the fit of the thread, and so I believe that would be more difficult for newcomers to the hobby and novices, and somebody with even a little bit more experience. It's I just feel that it's easy to make a thread, and if you go a little bit too far in, then all of a sudden it's loose and it's not working anymore. But in this particular case, that doesn't matter. It's not important in that respect, because the thread is only to lock the chuck onto the spindle. It's not to give the accuracy, in my estimation. It's the register. If you get a good fit between male and female register, then you've got a consistent, reliable trueness. So, just my opinion. I mean, I'm sure lots and lots of people are going to poo-poo what I say, and that's okay. I know now that with the increase in quality of machines and accuracy of CNC, then you can get those tolerances where you can get a nice fit, and even go to grinding the thread, which is probably the final best result. But for just for young people or older people that are coming into the hobby and they don't know very much, or they don't have a lot of experience, I think that this would probably be the better, easier way for them to achieve repeatability on a new chuck. if they're fitting. So now you have the standard. Now that's another thing. With these registers, there's a standard of fits. You can see it in the engineering Bible. You can see it in all kinds of data books and so forth. So one of the problems I have is I have two chucks that I got from Taig, and I don't know if they're manufactured by Taig, but probably farmed out maybe. But there is a certain standard, a plus or minus, they must have on their drawings and their quality control. Now I bought this lovely little chuck made by Bison. It's 2.5. I think it's 2.5. Let's have a look. Now 2 3/8 diameter, and it's got hardened jaws that are reversible, which surprised me because I'd never seen that before. Normally you get two sets of jaws, but in this particular case you just take the jaws out and turn them around the other way and it works. But anyway, it's quite a nice chuck, quite accurate, nice and small. Now if you look in there, you'll see that they also have this recess in here, and this is manufactured for a spindle, 3/4 16 spindle, and this one apparently is for a Taig, you see. Now they also do one of these for the Shoreline, and the Shoreline has the threads coming right up to the front here, or in this case up to the back. But the Taig, they have this plain section here which is supposed to be the register, but when you measure it, it's 5.10. It's 10,000 over ½ inch. So although they've manufactured this for the Taig, that thing there is doing nothing, absolutely nothing. They've screwed up in my estimation, because the Taig spindle is ½ inch diameter, or maybe 1/4 thou over, but the thread is ½ inch. Now this is 10 thou over size on ½ inch, so it's really completely useless, and all it's doing is relying on the threads to true it up so that it runs true when it's locked up. So I came across that problem, and so I've got 3 chucks here. I've got this one and the 4-jaw, which both have the same register, the same size, and I've got this thing here that is completely useless. I'm even surprised that it runs true on here, because it's just relying on the threads, and the threads, they don't look all that great. So you know, sometimes the old way is the best. That's what I think sometimes. Like, progress is not always better in some cases. So obviously Bison have a different standard than Taig, and probably Taig never intended for that plain part to be a register anyway. They just left it there like that because it was easier to screw cut on their machines. They're probably done on automatic machines, but it meant that they didn't have to go right up to the face, or recess it in, or put a parting tool in there to relieve the thread at the very front end. So that's why I say this might be a long a long video. Now, what I decided to do was, before I do anything else, I machined that, or semi-machined that adapter, so it's nearly size. The first thing I did was to make up an adapter that fits the plain section of the Taig chucks, and I've made it a nice snug fit, because I figure that when I screw it on, the threads of this stud, or this bolt that I've purchased, are going to be loose anyway, so it shouldn't interfere with anything. So I've made up a go plug, or go plug, just so that I have a micrometer reading. And so the idea is now that what is the idea? I'm getting carried away here. Okay, the idea is that I'm gonna progress with this system here, where the bolt threads are the white clearance, and the lined section is a insert that's going to go into the thread. It's going to be locked in now, obviously, and then that should give me a pretty accurate run on any chuck that I screw on there, any Taig chuck anyway. So I'll take this off. I'll take the camera down now and show you what kind of a reading I'm getting. I've already dialed in the back face of this chuck, and so I've got a dial indicator. Let's get it over in a decent bit. I've got a dial indicator there, and as you can see, hope you can see that, this is only a four place dial indicator, so it's about maximum half a thou out of center. It's about a thou run out. Again, it's Taig, so you can't expect something that like a hard hinge or some of this bigger stuff. Okay, now another thing that I want to show you while I'm doing this is I have a system. I think it's a fairly simple system of grinding tool bits. And first of all, what I'll do is I'll take the camera out to my grinder and show you what I did to achieve this. It's very, very simple, and you don't have to worry about angles or anything. I have this old grinder here that runs on Babbitts, and it was made by an old German engineer, I think anyway. I bought this when he died, and it serves me well. It's just give it a few drops of oil every now and again. Anyway, what I did was I put two large plates on and around the wheels there, and if you look at them like so, they're about on the center line of the spindle. Now, when you place a tool bit on the plate, lay it flat on the plate and go into the wheel, you'll get then a radius, and of course the larger the wheel, the bigger the radius. But I worked it out on with the size of the wheels and the size of a tool bit. I think it was a 3/8 tool bit, that by the time I've put a new tool bit on there and ground it to the top surface of the 3/8, you've got about 7 degrees of clearance underneath. And to me, on a small lathe, you can't take a real big, normally I don't think you can anyway, I never do, but I imagine that you can't take such a deep cut or feed that the depth of the cut is going to interfere with the relief that you have on the tool of 7 degrees. Now I could be wrong, that's just me, that's my opinion, but it works out very well because I can do all 3 surfaces of a tool bit just by placing it flat on there and just using the radius of the wheel and the height of the tool bit to give me a nice back off underneath the cutting edge. So that's something that might interest some people that are new to the hobby. It's entirely up to them. I like to have, I don't like this little tiny table they have on there. That's okay if you're in a ironmonger's and you want to stab a piece of angle iron on there and you need it for support, but I like it so that I can move the thing around. You don't have to worry about angles. If the tool gets blunt and it stops cutting, then you just take it out and put it back on here, and you've got the same form and the same radius and everything. It's just a matter of just touching up. Okay, so that's another little idea that might be handy for somebody. So I'll switch that off and we'll go back out to the lathe, and I got one other thing that I want to, I hope this is going to help people. It's nice to be able to help people. Let's see if I got in the right place. Yeah, that's okay. The other thing I just wanted to mention, and I don't have any interest in the company or the manufacturer, but I was on eccentric. I went on to eccentric engineering. It's in Australia, and I looked at a video that they have on there, and it shows a cutter that works better than high speed HSS. Not quite as good as carbide, but it's certainly an improvement over HSS. I believe it would probably last longer, and you can take bigger cuts and faster speeds. And this is it here. Here is, I just sharpened that the other night, and that's where I used the grinder. I got all 3 surfaces nicely sharpened, and it cuts very well. What I did was, what did I do with that? Oh yeah, I have a nice stone here, very fine stone, and all I did after sharpening, I just laid it